Hello, my name is Maxime TREMBLIN, and the main goal of my postdoc was to document for the first time the continuous isotopic signal in the North Pyrenean foreland basin during the beginning of the Paleogene. The Paleogene represents a period of major interest because it is punctuated by several transient hyperthermal events. The most pronounced and the best known of these being the Paleocene-Eocene thermal maximum, which occurred around 55.6 million years. This event is classically identified in the carbonate by a large negative carbon isotopic excursion. However, if numerous of studies proposed a Paleogene reconstruction of the isotopic signal in the southern part of the Pyrenees in Spain, in the northern part in France, an important succession of molasse, which was deposited during the Miocene, cover all the basin and complicate the studies of Paleogene sediment in the French part of the Pyrenees. So in this study, we take advantage of a coring realized by Total at Lusanier, which allows the study of the Paleogene sedimentary succession of the Aquitaine basin. And the main objective of this work was to identify the position of the PTM at this site by chemiostratigraphy. Indeed, if some biostratigraphical studies was realized in the past, they do not allow to pinpoint an accurate position of this event at Lusanier. Thus, if we look at the result, the high-resolution dataset obtained in our study show that an important negative excursion in the carbon isotopic signal occurred between 866 and 837 meters in depth. This main excursion is interpreted as the record of the PTM at Lusanier and allow the definition of the Paleocene-Eocene transition at 865.5 meters in depth for this coring. It's interesting to notify that this prominent excursion is preceded by a smaller one, interpreted as the pre-onset excursion. To complete this first result, other study site was added to the project. This new site allowed to propose a stratigraphical correlation between various formations across the Pyrenees. In addition of the isotopic signal, mercury analyses were also realized to observe if the perturbation of the carbon cycle recorded during this event can be linked to volcanism. Indeed, volcanism are a major source of mercury to the atmosphere and the ocean, and the study of anomaly in the mercury concentration is often used as a volcanism proxy. Our new data show that large mercury anomalies are recorded from the continent to the deep basin during the PTM and the POE. These results highlight a large disturbance of mercury cycle during this event. This large release of mercury is probably associated with the opening of the North Atlantic igneous province during the PTM. To conclude, this new data set allows the definition of a strong isochronous line across the Pyrenean domain during the PTM and bring a new lighting on the scenario which has triggered one of the most important global warming of the Cenozoic. Thank you for your attention.